Hi guys, welcome back to another practice session. In today's practice session, we're going to be looking at the difference of two squares. But before we begin looking at the difference of two squares exactly, we're going to look at perfect squares and their square roots. Now, for example, if I have the number 1 and I multiply it by itself, I'm going to get 1. Which says that 1 square is equal to 1, hence the square root of 1 gives us 1. So I can say that 1 is a perfect square because 1 can be written as 1 square. Suppose I had 2 times 2. So 2 times 2 gives me 4, hence 4 is equal to 2 square. So I can say 4 is a perfect square because it can be written as 2 square, and the square root of 4 is equal to 2. If I have 3 times itself, I'm going to get 9. Hence I can say that 3 square is equal to 9, and the square root of 9 is equal to 3. If I have 4 multiplied by itself, I'm going to get 16. So I can say that 4 square is equal to 16, and the square root of 16 is equal to 4. Now suppose I have x times x. Now x times x is going to give me x square. And I can tell that the square root of x square is going to give me x. So I can write x square as a perfect square. Suppose I have 3y squared and I multiply it by itself. My result would be 9y to the 4th power. Hence, I can write 9y to the 4th power as a perfect square, and I can write it as 3y squared all square. And if I were to find the square root of 9y to the 4th, I would get 3y squared. Now, let's use this concept to build on the difference of two squares. Now, the difference of two squares is when we have the product of a plus b times a minus b, and our result is equal to a squared minus b squared when we apply the distributive law. So if you observe a plus b and a minus b, you will recognize that we have the same first term and last term. However, our signs are different. So we have a plus sign and a minus sign. Now, our result gives us the square of the first term minus the square of the second term. Now, note briefly and note pantily that the A term and the B term are perfect squares. The A term and the B term are perfect squares. Now let's use this concept of a square minus b square is equivalent to a minus b plus a plus b. So let's write it back. We have a square minus b square is equal to a plus b times a minus b. And it doesn't matter if you want to put the a minus b before the a plus b. Multiplication is commutative, so it doesn't bother the result. Hence, now when we're applying difference of two squares, there are some observations that we need to make before we can go ahead. First, we need to identify that we have a perfect square subtracting another perfect square. So we have a perfect square term, perfect square, minus another perfect square. Now, in order to identify a perfect square, we want to know what term, when multiplied by itself, gives us a square. And that would be a times a gives us a square. Back our minus sign. Now, what number, when multiplied by itself, gives us 6? Gives us 36, and that number is going to be 6. Let me say the answer before the actual thing. So we have 6 times 6 gives us 36. Hence, this can be written as a square minus 6 square. And once we can have our result in the form of a square minus b square, our answer is now going to be a plus 6 and a minus 6. That's our answer for example 1. Example 2, we have 49t squared minus 25h squared. Now, another shortcut we could take, we could take mentally, that if I can find the square root of this term and the square root of this term, then automatically both of these numbers, and the square root gives me a whole number, then I can identify that these are perfect squares. So 7, square root of 49 is 7, and t times t gives us t squared. The square root of 25 is 5, and h times h gives us h squared. So we know that 49t squared is the same thing as saying 7t multiplied by 7t minus 5h times 5h. So now we have 7t squared minus 5h squared. So we have one perfect square subtracting the other perfect square. So we have the form a squared minus b squared is equal to a plus b minus, times a minus b. So our result is going to be 7t plus 5h and 7t minus 5h. Example 3. Now we have s squared minus 4 over 9. So identify that we have two perfect squares. Now if you're in an exam and you're feeling discombobulated with your numbers, or you get big numbers, just find the square root easily. See if when you find the square root on your calculator you get whole numbers. Alright? So we know that s squared is s times s minus, alright, so you say the square root of 4 is 2 and the square root of 9 is 3. So we get 2 over 3 times 2 over 3. So it's the same thing as saying s squared minus 2/3 square. So hence we get it in our form, a squared minus b squared is equal to a plus b times a minus b. So we have s minus 2 over 3. That's one factor, and our other factor is s plus 2 over 3. Now we know x squared by now. X squared times x is equal to x squared. And we know that the 2 times 2 give us 4 and 5 times 5 give us 25. So all of this is a perfect square. Subtracting y times y give us y squared. And 4 times 4 give us 16. So first step is gone. We identify that we have a perfect square, subtracting another perfect square. So hence we have 2x over 5 minus y over 4, both squared. So our factors are 2x over 5 plus y over 4 and 2x over 5 minus y over 4. Now example 4. Now most students get flustered when they see 1. Remember, 1 is the same thing as saying 1 times 1. And the square root of 169 is 13. Hence 13 times 13 gives us 169. So we have our two perfect squares subtracting each other. So we can say 1 times 1 minus 13x times 13x. So we have 1 square minus 13x all square. So our factors are 1 minus 13x times 1 plus 13x. That's our factors, 1 minus 13x and 1 plus 13x. Now we have a plus b all square, and we can treat a plus b all square as one term minus 1. Now automatically this can be written as a difference of two squares easily, because we have a plus b is already in the form of a square. So we need our 1. 1 square is the same 1, so we have 1 square. So we have our form a square minus b square, and that is equal to a plus b times a minus b. So hence, all of this treat a plus b as our a term. So our factors would be a plus b minus 1 and a plus b plus 1. Those are our two factors. And you could put an inside bracket if you want to, or not. So our answer could be written as that, or a plus b minus 1 and times a plus b plus 1. Thanks for watching. Like, comment, share, subscribe, and see you in our next practice session.